Hello there, welcome to my channel. In this video, we will be solving another cool problem where we have 2 to the power of x minus 2 to the power of y equals 2016. And obviously, we want to solve for x and y such that x and y are positive integers. Great, so let's go ahead and do that. And let's go ahead and start with the fact that 2016, which is the right-hand side of our equation, is positive. Therefore, the left-hand side must be positive, which means that 2 to the power of x minus 2 to the power of y is positive, which means that 2 to the power of x is greater than 2 to the power of y, which means that x is greater than y. Great. So x and y are two positive integers, and x is the greater one. So that means that I can go ahead and find some integer like n and say that x equals n plus y. And this is kind of obvious, right? Because let's say x equals 10 and y equals 8. Then I can go ahead and say that n must be 2. Or let's say x equals 5 and y equals 1. Then I can say that n equals 4. So for any two non-equal integers, I can find an integer that I can add to the smaller one and get the bigger one. So that's true for any two integers. Next, let's go ahead and rewrite our original equation. So we had 2 to the power of x minus 2 to the power of y equals 2016. And since we assume that x is equal to n plus y, I can go ahead and say that 2 to the power of n plus y minus 2 to the power of y equals 2016. Next, I can go ahead and use the rules of exponents and replace this with 2 to the power of n times 2 to the power of y. So we have 2 to the power of n times 2 to the power of y minus 2 to the power of y equals 2016. Next, let's go ahead and pull out this 2 to the power of y. So we're going to have 2 to the power of y times 2 to the power of n minus 1 equals 2016. Awesome. Next, let's go ahead and factor out 2016. So 2016 is 2 times 1008. 1008 is 2 times 504. 504 is 2 times 252. 252 is 2 times 126. 126 is 2 times 63. And 63 is 9 times 7, which is the same thing as 3 squared times 7. So 2016 is 1, 2, 3, 4, and 5. It is equal to 2 to the power of 5 times 3 squared times 7. So basically we have 2 to the power of y times 2 to the power of n minus 1 equals 2 to the power of 5 times 3 squared times 7. And we want to solve for y and n. But notice that this and this are even, and this and this are odd. So I can go ahead and say that the even factors are equal, and the same thing goes for the odd factors, which means that 2 to the power of y should equal 2 to the power of 5, and 2 to the power of n minus 1 should equal 3 squared times 7. So let's go ahead and use these two equations to solve for y and n. Obviously, from the first one, I'm going to get y equals 5. And the right-hand side of the second equation is 63. Therefore, 2 to the power of n equals 64. And 64 is 2 to the power of 6. So 2 to the power of n equals 2 to the power of 6, which means that n equals 6. But notice that we wanted to solve for x and y. And remember that x equals y plus n. Therefore, x equals 5 plus 6, which equals 11. Great, so we solved for x and y. And for the final thing, let's go ahead and check these two values out and see if they are valid. So based on the original equation, 2 to the power of x minus 2 to the power of y is supposed to equal to 2016. And we found out that x is equal to 11 and y is equal to 5. Therefore, based on these values, the left-hand side of our equation is going to be 2 to the power of 11 minus 2 to the power of 5, which is equal to 2048, which is 2 to the power of 11, minus 32, which is 2 to the power of 5. And this subtraction is going to be 2016, which is the right-hand side of our equation. So x equals 11 and y equals 5 does satisfy our equation. Therefore, it is a valid solution. Great. So this brings us to the end of this video. Thank you for watching this. Hopefully, I will see you later. Goodbye for now.